Hello dear students, welcome to the YouTube channel. In this video I'm going to discuss about electric dipole. This concept is from the chapter electric charges and fields. This is the first chapter in second PUC. Okay, so welcome to the YouTube channel. If you have not subscribed yet, please do subscribe and share it to your friends if you feel it is useful. Okay, so let us discuss about the electric dipole here. So what is this electric dipole? Dipole. So what is this electric dipole? Let us learn. See, first of all, let me read the definition for this. A pair means two charges will be there. A pair of equal and opposite charges separated by a small distance is called an electric dipole. There is one more dipole, that is magnetic dipole. Okay, I'm not discussing about magnetic dipole, it is electric dipole. So here a pair of means two equal and opposite charges separated by a small distance is called an electric dipole. Let me draw an example, diagram for this. See, two equal charges means what? Q and Q. Opposite means opposite in sign. So let us consider this is plus, this is minus. Okay, separated by small distance from their centers, that is 2a. Okay, so 2a or 2l. So why 2a? See, we consider the distance from the center. From center, this distance is a and this distance is a. A plus a is 2a. Clear? Now, this is called electric dipole. A pair of equal and opposite charges separated by a small distance is called an electric dipole. Sir, give me an example. Let me give an example here. Example. Okay. So, for example, I can give HCl. H plus Cl minus. You have heard about it, right? They are separated. Those two atoms are separated, or elements are separated by small distance, HCl. Okay, so best example is HCl. Okay, or you can consider water molecule H2O, or you can consider carbon monoxide. This is also an example. Okay, like that you can consider ammonia. I think NH3, right? Ammonia. Okay, so like that. So different elements you can consider, they are like they are considered as an electric dipole. This is one thing very important for a board examination. They directly ask you define electric dipole. Next, what is electric dipole moment? Okay, so here let me write electric dipole moment. So now let me define this electric dipole moment. Before that let me draw the diagram again. Two equal and opposite charges separated by small distance is called electric dipole. Okay, 2a is the distance between them. Now electric dipole moment. See, this actually represents the strength. What is the strength of electric dipole? ಎಷ್ಟು strength ಇರುತ್ತೆ electric dipole ಗೆ ಅಂತ. And it is a vector quantity. Vector quantity means it is having both magnitude and direction. And there is a formula for that, and it is represented by the symbol P, electric dipole moment. So if it is a vector quantity, what is the direction? See, direction of electric dipole moment is always from negative charge to positive charge. It will be towards negative what is that positive charge from negative charge. Do remember this, they can ask for 1 mark. What is the direction of electric dipole moment? Okay, so there is a reason for that also. I let me give that what is that left that concept to you, leave that concept to you to understand why electric dipole is directed from minus charge to plus charge. Okay, if you know the answer, just comment in the comment section. If you don't know, try to find it. Okay, now electric dipole moment, there is a formula for that. Before that, let me explain what is or let me define what is electric dipole moment. See, electric dipole moment, directly right, electric dipole moment is a vector quantity and it is whose magnitude is equal to product of magnitude of any one of the charges, magnitude of either of the charges and distance of separation or dipole length or distance between plus charge or minus charge. So mathematically, if I write, you can easily understand. So electric dipole moment is equal to, it is the product of, let me write into, so it is equal to product of magnitude of any one of the charges. You can take this one or this one, but you have to take magnitude. Let me write Q. And the dipole length, what is the length of the dipole? 2a. So this is called electric dipole moment. And I have told you that is electric dipole moment is a vector quantity. So if you write this in scalar, you can write like this, P is equal to 2aq. But in vector, we have to write like this. So 2 is a scalar quantity, a is a vector quantity, and q is a scalar quantity. This is how we represent the electric dipole moment in, what is that, vector form. This is in scalar form, this is in vector form. Next, one more question that arises here is, what is the SI unit of electric dipole moment? See, for charge it is coulomb. Okay, for length, dipole length, it is meter. So coulomb meter is the SI unit of electric dipole moment. Okay, so these are the very important concepts from electric dipole moment, dear students. Now let us discuss about what if we place this electric dipole moment, electric dipole in, what is that, electric field. Next concept, force and torque acting on electric dipole placed in uniform electric and let us not discuss about magnetic field here, because that we can discuss in moving charges and magnetism. Now, so force and torque acting on electric dipole placed in uniform electric field, very important concept for board examination as well as competitive examinations. Okay, now let me explain this in detail. Have some patience. Okay, now let me consider uniform electric field here. This is how we represent uniform electric field, equidistant parallel lines. So this is the direction of electric field. Now if we place one electric dipole here, so let us consider this is positive charge plus q, this is minus charge minus q. See, electric field lines are directed in this direction. From where they are coming? From positive charge towards where they are going. Let us consider negative charge, because electric field lines originate from positive charge and ends at negative charge. So since electric field lines are moving in this direction, I can sense they are coming from positive charge and moving towards negative charge or infinity. Okay, so if this is positive, this is also positive, what is the nature of force there? Positive repel each other, so force will be in this direction. So how much force will be there? You already know, that is electric force is given by Q into E. ಗೊತ್ತಿದೆಯೋ ಇಲ್ಲೋ ನನಗಂತೂ ಗೊತ್ತಿಲ್ಲ. ಸಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಈಸ್ ಗಿವೆನ್ ಬೈ 1/4 Pascal q1 q2 by r square coulombs force, right? Otherwise we can write that like this, because electric field is defined as force acting on unit positive charge. Okay, now let me consider F is equal to q into E. So since it is positive, this side it is negative, so nature of force will be attractive, and that force will be acting in this direction. Okay, so F is equal to minus q into E, because it is minus charge, and F is opposite to electric field. That's why we can write minus sign here. Okay, now what is the net force? Let me write the net force. Net force is equal to force due to positive charge, force on positive charge plus force on negative charge. So net force is equal to QE plus minus QE. Okay, you can write this in vector form also. You can write. Okay, so QE minus QE, both are opposite vectors having the same magnitude, so net force acting on the dipole is 0. Very important concept. Net force acting on a dipole is, what is that? 0. Now second thing is what? We need to find out torque also. Let us find out torque. Hinge find out ಮಾಡೋದು. We should know the formula for torque. What is the formula for torque? Torque is equal to force into perpendicular distance. ಆಯಿತಾ? ಸಿ ಫೋರ್ಸ್ ಏನೋ ಇದೆ, ಎಷ್ಟಿದೆ ಫೋರ್ಸು? q ಇಂಟು ಇ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್ ಯಾವುದಪ್ಪ? ಸಿ ದಿಸ್ ಈಸ್ ದ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್. ಐ ಡೋಂಟ್ ನೋ ವಾಟ್ ಟು ಡೂ. ಲೆಟ್ ಅಸ್ ಫೈಂಡ್ ಇಟ್. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಈಸ್ ಥೀಟಾ. ವಾಟ್ ಈಸ್ ಥೀಟಾ? ದಿಸ್ ಈಸ್ ಥೀಟಾ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಸೊ ಸೈನ್ ಥೀಟಾ ಈಸ್ ಈಕ್ವಲ್ ಟು ಆಪೋಸಿಟ್ ಬೈ ಹೈಪೋಟೆನಸ್, ರೈಟ್? ಸೊ ಸಿನ್ಸ್ ಇಟ್ ಈಸ್ ಅ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್, ದಿಸ್ ಲೆಂತ್ ವಿಲ್ ಬಿ ಹೌ ಮಚ್? 2a. Dipole, two equal and opposite charges separated by small distance 2a. So now if I write sin theta here, sin theta is equal to opposite by hypotenuse. Opposite that we need to find out, we don't know, perpendicular distance divided by hypotenuse, it is 2a. So 2a will come this side. 2a sin theta is equal to opposite. So this opposite length, this length is 2a sin theta. That is nothing but perpendicular distance. Easily we got this. 2a sin theta. Now torque is equal to force is q into E, magnitude of force, into 2a sin theta. Here dear students, 2a into q is what? Electric dipole moment. Just now we have studied. We have not studied this in last Janma. We have just studied here. So now itself P sin theta. So can I write this one in vector form? This is the torque acting on the dipole. So what is what is that vector form? P cross E. It is also vector. Okay. So torque acting on a dipole is given by this. Now here, see, what is this? This torque value vary with respect to theta. If you substitute theta value as 0, torque will be 0. If theta value is 90 degree, torque value is maximum, like sin theta is 1, sin 90 is 1. Okay, like this it will vary. So we'll discuss about that in future classes. As of now, do remember this theory concept. Okay, this is all about this. We'll meet you in the next video. If you like the video, please subscribe. If you have subscribed, like it. If you have liked it, share it. Thank you.